This is the last problem in chapter 3 for week 2's homework. And what it is the precession around this constant magnetic field. Why is that constant? In the rotating reference frame, x hat prime is constant. And so this whole, this total vector with z component and x hat prime is now constant. And from chapter 2, we know how to think about that. If I have a magnetic moment here, it will precess around this axis. It will precess around this axis in, sure enough, this clockwise fashion, looking back at it. And my magnetic moment, starting at this point, will trace out then a circle around this precession, around that axis. I did a terrible job of drawing a circle here, but I tried to draw this precession circle down here. Now, our goal is to relate the angle alpha between mu and its original direction and the precession angle. I called it capital omega. That's omega effective t. Omega effective t is just gamma. Omega effective is just gamma b effective. That angle, can I relate that angle to this angle? Yes, because in fact, both of them come into a nice isosceles, separate isosceles triangles with a common side. That common side is right here. If I can draw this nice and straight. Notice that side, here it is here, and this side, of course, are equal. It's that same magnetic moment. And that's an isosceles guy, and this angle alpha is what I want. And so I use the law of cosines. L squared equals mu squared plus mu squared minus 2 mu squared cosine alpha. So L squared is related to cosine alpha, but L squared is also related to this precession angle. Why? Well, because that's also a side for another isosceles triangle. Oh no, my God, I just drew this horribly. Anyway, notice this side and this side, they're equal. They're mu sine theta. They're the side opposite in this right triangle here, or the side opposite on this right triangle here. You know, this is into the plane, into the paper. And that's an angle theta too. So this is mu sine theta. That's mu sine theta. Here they are, I've rewritten them. Mu sine theta. And that the closing of that isosceles triangle, that L, that's that same L that I had here. Law of cosines again. L squared equals mu squared sine squared theta plus mu squared sine squared theta minus 2 mu squared sine squared theta times cosine of capital omega. And by the way, you can use a trig identity, you know, an half angle formula here to finish this guy out. You're just going to take the L squared you got from here, set it equal to the expression that you get for L squared from there, and it drops out nicely. But keep in mind this picture of this precession that we're undergoing here.